Okay, today we are going to discuss angle relationships in triangles. There's a few relationships, some things I know you know, and some things may be new and exciting news to you. So let's take a look at this. The first theorem we have here is the triangle sum theorem, which just says the sum of the angle measures of a triangle is 180 degrees. And because we know that, we can say that the measure of angle A plus the measure of angle B plus the measure of angle C all have to equal 180 when you add them together. This means if you know two of those angles, add them up, subtract it from 180, you'll know the third angle also. So you can use that. We'll use it if we just know two angle measures. We'll also use it from a little algebra. This is like a problem in your book with some constellations, some stars, and it says find each angle measure. Well, we're going to start with our triangle sum theorem, and we'll write the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And then, as we always do in these cases, we'll substitute in our expressions: 2y plus 10 for angle A, 4y minus 8 for angle B, and 3y plus 7 for angle C. Simplify, add your y terms. 2 and 4 is 6, 9y. Then add your numbers. You've got 10 minus 8 is 2, plus 7 is 9. And that's going to equal 180. Just solve it for y. Take away your 9, you get 9y equals 181. 171, excuse me. Divide by 9, and y equals, 9 goes into 17 one time with 8 left over. 9 goes into 81 9 times. So y is going to equal 81, or 19. And now we just find each measure. The measure of angle A is 2 times 19 plus 10. So 38 plus 10 is 48. The measure of angle B is 4 times 19 minus 8. Well, 4 times 20 is 80. Take away 4 because it's only 19. So 76 minus 4, 68 degrees. And the measure of angle C is 3 times 19 plus 7. So 3 times 9 is 27. Carry the 2. 3 times 1 is 3. 4, 5 plus 7, 64 degrees. Now to check that real quick, I go 8, 16, 20. Put down the 0, carry the 2, 4, 10, 16, 18. When you add up all three of these angles, you end up with 180, so you know you did it right. Okay? So that's how you use that theorem. Now corollaries to this are, well, if the three angles together equal 180, then if you have a right triangle where one of the angles is 90 degrees, the two acute angles of this right triangle have to equal 90. So the corollary in words is the acute angles of a right triangle are complementary. And the other corollary is if you have an equiangular triangle, which by the way is also equilateral, one kind of leads to the other, then you know all of these angles when you add up equal 180 and they all equal each other. So you can say 180 divided by 3 is 60, and each of these angles must be 60 degrees. So the second corollary is if you have an equiangular triangle or an equilateral triangle, the measure of each angle is going to be 60 degrees. Now this third theorem is a little bit more exciting, but I think you can follow me on this. Now let's start with this diagram. Okay, we have a triangle and we're going to extend one of the sides past the angle. And if we do it, we'll make an exterior angle to this triangle. And this angle is adjacent to angle 3, so these two are adjacent, and this is the exterior angle at 3. Now these are both interior angles that are not adjacent here, so we call them remote interior angles. Remote because they're far away from this exterior angle, just like a remote island would be far away from civilization. So here's what we know about the relationship between these angles. I know the sum of these three equals 180. That's what we just learned. I also know that angle 3 plus angle 4 equals 180 from the linear pair theorem. We learned that in chapter 1. So I can put angle 1 plus 2 plus 3 equal to angle 3 plus angle 4 by substitution. Okay? And if I do that, I take away the measure of angle 3 from both sides. That's just my subtraction property of equality. And I'm left with this angle plus this angle equals this outside angle, this exterior angle. So the exterior angle theorem states that the sum of the remote interior angles, these two angles right here, is equal to this exterior angle measure out here. And we are going to use that and use that and use that. So please, write it in your notebook, remember it. Let's use it right now. Okay. Using the exterior angle theorem. Here's a nice easy spot. I know that the measure of angle A plus the measure of angle B has to equal this exterior angle out here, the measure of angle BCD. Well, you might get something like this. We've got some numbers, so I'll just substitute in my numbers. And you know what? All I have to do is simplify. 8 and 2 is 10. Put down the 0, carry the 1. 6 and 2 is 8, plus 1 more. And the measure of angle BCD is 90 degrees. Doesn't look like it, but remember we discussed how you can't assume angle measures. You've got to figure them out. So, you know I didn't draw that real well, but you've got the idea. Now, this gets a little bit harder. Let's call this X, Y, Z, and we'll give it a value at W. And here's what we know here then. These are my interior angles. So the measure of angle X plus the measure of angle Y has to equal the exterior angle here, the measure of angle YZW. And I can plug in expressions for these angles. Here for X I have 2X minus 12. Y, they didn't give me any numbers, but we all know what that little box means, 90 degrees. And that's going to equal 5X plus 18. Now, to solve, I need to simplify first. So I have 2X, 90 minus 12. 90 minus 10 is 80, so I'll take away 2 more, and I'm at 78. So I've got a positive 78. Now I need my x terms all on one side, so I'll take 2x away from both sides of my equation and get 78 equals 3x plus 18. Want those x terms alone, so I'll take away 18 from both sides and get 0, 8 minus 8, and 7 minus 1 is 6, equals 3x. Now when I divide by 3, I've got 20 equals x. But that did not find for me the measure of my angles. But because of this, I can now say I've got a tool for this. The measure of angle x is going to be 2x minus 12. By substitution, I can put a 20 in there and get 40 minus 12. Well, 40 minus 10 is 30. Take away 2 more, and I'm at 28. I know the measure of angle y equals 90 because that was given to me. And the measure of angle YZW, well, it better be 90 plus 28, 118. Because it should be these two. But let's make sure I did my math right. 5 times 20 plus 18, 100 plus 18, 118. And my check, my interior angles should be the same. So if I add up my 90 and my 28, it equals my exterior angle, so I know that I did that one right. So we're going to use this exterior angle theorem quite a bit, and you want to be looking at these two remote interior angles, the angles that are inside the triangle but far, far away from the exterior angle here. those two must be the same, have the same sum as that interior angle. We have one more relationship to look at in this triangle. And this is one you're going to go, seriously, Mrs. Klein, we know that. Here it is, the third angle theorem. If two angles of one triangle, notice we've got them marked, are congruent to two corresponding angles in another triangle, well, that third pair of angles is going to be the same also. They're also congruent. So if you know two pairs of corresponding angles are congruent in two separate triangles, you know the third pair is true, which makes sense because they have to equal 180. Okay? So let's see. To use this theorem, we might be given something like this. I've got PNM, RST, and I look and I see angle N is congruent, got two tick marks, to angle S, which also has two tick marks. And I also know here's R with 1 and M with 1. So angle M is congruent to angle R. So that tells me by the third angle theorem that the measure of angle P equals the measure of angle T. Now, if I want to find these angle measures, I certainly can. I can write down that 2x, this is the x squared equals 4x squared minus 32, and I can just use my algebra skills to solve it. The first thing I'm going to do is take 2x squared away from both sides. That will leave me with 0 on this side. No worries, 0 is a fine answer to have on one side. And now I'm going to add 32 to both sides because I want my variable term alone, and I'll get 32 equals 2x squared. Divide by 2 and get 16 equals x squared. Now I could go further, but I see no need to because the variable in both these expressions is x squared. So that tells me that the measure of angle P is 2x squared. So if I put in 16 for x squared, I've got 2 times 16, and I have 32 degrees. The measure of angle T, hopefully, is 32 also because I set them equal. 4 times x squared minus 32. I've got 4 times 16 minus 32. Well, 4 times 6 is 24. Put down the 4, carry the 2. 4 times 1 is 4, 5, 6, minus 32. And I get 32 for the measure of angle T also, which I should. So, third angle theorem, we use it to find angle measures. If we know two pairs of angles are congruent, we can set that third pair congruent and find them. So hopefully you will find this helpful as you do your homework, and see you in class.